All right, welcome. Let's work Algebra 2 Quiz 12.1, but quickly. So we're going to determine if this is linear, quadratic, or exponential, and we're going to justify our answer. So we're going to look at kind of the difference in the terms, and to go from 36 down to 24, we're losing 12. So that's minus 12, and then decreasing from 24 down to 16 is a decrease of 8, and then decreasing from 16 to 12, that's a decrease of 4. Okay, now this is form B. I'm just going to point out, evidently I'm starting with B this time. This is not the same difference, so it's not linear. Linear's out. Okay, if I see the same second difference, then I could say it's quadratic. So to go from negative 12 to negative 8, I added 4, and then same story here. Okay, so I'm going to conclude quadratic. If you had started by testing to see if this was exponential and doing like, 24 divided by 36, see, okay, that's 2/3. But then if you did 16 divided by 24, same story, 12 divided by 16. Okay, that's not the same ratio. Okay, so it wasn't exponential. Okay, it was just quadratic. And then for some reason I thought it was both. Okay, on this one, we're going to just check the first difference, decreased by 12. And if you're unsure, you can just use the calculator. This is a decrease of 12, and this is also a decrease of 12. If I'm seeing the same first order difference, that's going to be linear. Okay. If h is exponential, what's the value of a? And so that means I'm multiplying by the same number each time. So I say, what did I multiply 12 by to get 18? 1.5. So I multiplied by 1.5 here, I'm going to multiply by 1.5 here, and then I'm going to multiply by 1.5 again. So A is going to equal 27 times 1.5, which is going to be something we can use the calculator for. I'm trying to go too fast. And that's going to be 40.5. All right, now we've got colony of bacteria, and it's growing exponentially, so I'm going to need to go in the stat menu and edit the lists. Okay, so I'm going to put in my t-values, and I'm going to put in my population values, 489, 656, 783, 830, and then I'm going to run exponential regression. Okay, on those, I'm going to store the regression equation into y1, and then it gave me a times b to the x. So it's 409.885 times 1.801 to the t, and this is p of t. All right, so we're going to use the model to predict the population of the colony at time t equals 2, and I'm going to say y1 of 2 because we plugged in our regression equation into y1, right? So if I plug in 2, which would be, after t equals 1.2 up here, I should see something bigger than 830, I get 1,328.890. 1,328.890. And then we're going to use the model to predict the time at which the population of the colony surpassed 100. Right? So we've got, y1 here. And, okay, we needed to change this to 1,000 because the population started off bigger than 100, so that wouldn't really make any sense. We're going to go and we're going to say 1,000 here. And I'm going to graph both of them and see where they intersect. But I'm going to need to give myself quite a bit more in the y direction. Maybe I'll go 0 to 1,500 at a step of 100. And we're going to see where the two curves intersect each other, and that will give us the value of t that makes this true. So I'm going to say, really what I'm solving here, I'm not sure where 1,000 is, but 409.885 times 1.801 to the t equals 1,000. And then we're going to calculate the intersection between blue and red, give it a guess, and we get t equals 1.517. Then the next one is a falling object, so it's going to be a quadratic regression. Okay, these projectiles. Right. And then I'm going to go into the stat menu, edit the list, 2, 4, 7, 8. And then that's going to be 1300, 1130, 6, no, that's 130, 670, and 460. And stat, calculate quadratic regression. Okay, we can store this into y1. And then we're going to have, all right, negative 13.799 t squared minus 1.907 t plus 1358.842. That's going to be h of t. And so predict the time when the object hits the ground. So it'll just be like find the zero. So I'm going to just hope that that happens in the standard window. So I'm just going to graph y1. See it going up. That's probably not realistic. You know, it's just dropped or something. And I'm hopeful that it's going to come back. It might happen soon. Yeah, there we go. All right, so we're going to calculate a 0. It looks like it's between 9 and 10. And there we go. Okay, that's t equals 9.854. Nearest tenth of a second would be 9.8 or 9.9 seconds. Okay. And this was us finding the time where h of t was equal to 0. All right, that was form B. Let's do form A, and let's keep it pretty quick. Okay, so number 1, determine if it's linear, quadratic, or exponential. Okay, if it goes from positive to 0, it's not going to be exponential, at least in this class. So 21 to 14 is a decrease of 7, and then 14 to 7 is also a decrease of 7, and a third decrease of 7 makes me know that it's constant first difference. This is linear. And over here, if I've got 27, 18, 12, and 9, and I decrease by, let's see, looks like a decrease of 9, a decrease of 6, and a decrease of 3. This is going to be quadratic because the second difference is constant, positive 3. So I'm going to say quadratic. Okay. And if I'm looking at a continuous function here and it's exponential, what's the value of a? So I have to figure out what am I multiplying when I went from 32 to 24. Okay, so 24 divided by 32 is going to be 0.75. So I'm multiplying by 3/4. Okay. And so I'm going to multiply by 3/4 again. So 18 times 3/4 is going to equal a. So I'll just multiply that by 18 and get 13.5. So a equals 13.5. And on the back, we're going to say we've got a colony of bacteria that's growing exponentially between 0 and 2 days. So if we're going to be doing an exponential regression, we should probably clear the RAM on our calculator. Go into the stat menu, edit the lists, 0.4, 0.8, 1.1, 1.4. Back 430, no. 430 into the second column, 566, 697, and 858. Okay, I'm going to quit out there, go to the stat menu, calculate an exponential regression, store that regression equation into y1, calculate, and then we get 325.963 times 1.996 to the t. And then use the model to predict the population of the colony at time t equals 2 days. So I'm going to plug in on y1. So I'm going to call for y1, plug in 2, and get 1,298.219. Nearest whole number, so 1,298. Let's say that's p of 2 equals. And when did the population of the colony surpass 1,000? So that'll be, so find the solution to p of t equals 1,000. So we're going to go over here. I'm going to say this equals 1,000. And, okay, we see it's going to be just like based on the table. This is going to be a little bit, maybe around between 1 and 2, right? So I'm going to say, right, the window we're looking at, okay, I'm going to actually narrow down the x window to be 0 to 2 because I know it's got to be in there. And the y minimum and maximum, I'm going to say 0 to 1,500, kind of like I did when I was doing Form B. is going to take a while. This calculator graphs very slowly. But it gets the job done. So, okay, there we go. And we're going to calculate an intersection between blue and red. We're going to give it a guess. And 1.622. So that's t equals 1.622. All right, and then there's an object that's falling out of the sky, and it's quadratic because projectiles, they move in parabolas. So I'm going to go to the stat menu, edit the lists. Okay, I generally recommend that you just clear the RAM, but it's okay. 2, 4, 7, 8, 1350, 1170, 660, and 440. Okay, we're going to run a quadratic regression. I'm going to store it into Y1. And we've got, whoa, I've typed something in wrong here, right? That should be a negative quadratic. Okay, let's see what I did here. Let's edit the lists. 2, 4, 7, and 8. 1350, 1170. So those double numbers in this calculator prove really troublesome. So we're going to calculate a quadratic regression again. That's more like it. Negative 15. 071 t squared minus 1.653 t plus 1414.744. Okay, and that's going to be my equation. And then use the model to predict the time when the object hits the ground. We're going to graph this and see when it goes 0, but maybe on the window I'm going to go X, no, I'm going to zoom standard, and then adjust from there. Okay, I remember last time it was very close to 10, so I might just go 0 to 20 this time instead. Okay, I've got it. Let it finish graphing, even though it's graphing off the screen. Okay, how long is this going to take? Okay, there we go. We're going to calculate the 0. Looks like it's between there and, okay, I'm already in the negatives, so that would be t equals 9.6, nearest tenth of a second. All right, and that's going to be all for this one. Thanks for watching.